Today, we're going to look at heat transfer and review a little bit. So, our essential question, which is the big question we're asking, right? The question that we're trying to answer is what solution can we dream to solve problems with heat in our world? But we're going to focus today on explaining the effects of heat transfer by conduction, convection, and radiation. So, before we get started, I want you to do a quick temperature check just to see how you're feeling today. If you're in the orange or the red, it may not be a great, or a yellow even, it may not be a great day or a great time for you to work. But if you're in this green or blue area, then let's keep going. All right, so first, what do you already know about heat? I want you to pause me and think about all the things you already know about heat and brainstorm them in your journal really quickly in the N section. That's the top left part of your journal. The words you're going to need to know for today are thermal energy, conduction, convection, and radiation. And all of this is in the presentation that goes with this video. So if you need to pause me and read these words, feel free to do that. But if you need to go into more detail, just look at the PowerPoint that I have attached also for this. Okay. Conduction. As a review, conduction is when thermal energy or heat passes through objects that are touching. So we have a spoon in a mug of hot liquid of some sort. It could be hot cocoa, it could be coffee or tea or just hot water. But this spoon is getting hot by conduction because it is touching the liquid. Conduction, heat passes by touch. Convection is when heat travels in a cycle. So you'll see that warm fluids rise, and as they cool off, they start to fall back down. They warm up and they rise, and they cool off and they fall back down. We see this as like bubbling when something boils or bubbles. That's what we see. What's actually happening is this cycle. The warm part rises, the cool part falls. Convection only happens in liquids and gases. Last but not least, we have radiation, and that's when heat transfers through empty space. It travels in electromagnetic waves. Okay, this is not the same as waves you would see like in the ocean or in water. This is not water waves. These are waves that can travel through empty space. We see them as sun rays, as light, but you actually feel them as heat. You can feel them. Everything has some sort of electromagnetic waves. Like humans, we have electromagnetic radiation that comes off of us. Any object really does, but we don't have as much as the sun, obviously. The sun heats us up from 93 million miles away. So, what I want you to do is pause me after each one of these, and I want you to take a guess for what kind of heat transfer it is. Is it conduction, convection, or radiation? So, for the first one, scenario one, Michaela is making s'mores with her cousins and notices that her jacket zipper is getting really hot while she stands by the fire. How did her zipper become warmer? Did her zipper become warmer by conduction, convection, or radiation? Go ahead and pause me now and take a guess in your journal. If you said radiation, you are correct. It was by radiation. So let's look at scenario two. Jorge is working with his grandpa on an old car. They are using fire to melt metal for a new bumper. How did the metal become hot enough to melt? Go ahead and pause me and tell me, was this conduction, convection, or radiation? If you guessed conduction, you are right. The metal has to touch the fire in order to get hot enough to melt. The last one, Juliana and her hermana, her sister, are running in the playground. They notice that after an hour, their dark hairs become really hot. How did their hair become warmer? Go ahead and pause me now and tell me, did their hair become warmer by conduction, convection, or radiation? If you said radiation, you would be correct. Their hair became warmer by radiation. Nicely done. Okay, for this last one, I want you to write it down in your out, which is the bottom left part of your journal. I want you to pause it and answer, and then you can go ahead and add that to your exit ticket when you submit it for me at the end of this assignment. I'm going to read it for you, and then we'll be done. Cecil is going swimming in the pool and notices that when he dives down deeper, the water is cold, but when he swims back up to the top, the water is warm. How can this